Welcome to the Deep Dive. Today we're tackling a really core challenge, something every educational place is grappling with. How do you stay ahead, or even just keep up, with technology changing so fast? And we've got a fascinating way in an internal document, actually. It's the 2025 Electrical Engineering Curriculum from Institut Teknologi Sumatera. Itera, for short. Yeah, this isn't your usual course catalog. It's more like a strategic plan. Gives us a real peek behind the curtain at how an engineering program actually evolves. Our mission here is simple. Pull out the key insights, the important bits, maybe some surprising facts from this dense document. Basically give you a shortcut to understanding where engineering education might be heading. Okay, let's unpack this.
What's fascinating here, I think, is that we really get to see the thought process, how they're figuring out how to train the next generation in such a critical field. And like you said, it's way more than just courses. It's a strategic response to global shifts, regional needs, really spelling out the skills they think engineers need tomorrow.
Right. So the big question first. Why the massive update? What pushed Itera to rethink their whole electrical engineering program for 2025? Well, the document itself is pretty clear. They see the curriculum as the main foundation for higher ed. And I mean, we're all facing these huge challenges of the Industry 4.0 era and Society 5.0. These aren't just buzzwords, are they? It means they need graduates who are, well, more than just competent. They need to be innovative and genuinely ready to compete nationally and internationally.
Absolutely. And it's not just them deciding this in a vacuum.
No, exactly. There's that mandate for change.
Yeah.
Things like accreditation standards. They mention IAPS .C6 in Indonesia, basically saying you have to update your curriculum every 5 years.
Keeps things fresh, I suppose.
Yeah.
Tries to.
Yeah, keeps them relevant. So this 2025 update, it's a mix, right? Internal reviews, crucial feedback from alumni, from employers, and looking hard at what other top universities are doing.
It's a pretty comprehensive approach. And if we connect this to the bigger picture, like you mentioned, it's a direct reaction to these big trends. Itera is quite specific about wanting to weave in things like AI, artificial intelligence, renewable energy, industrial automation, and the energy transition is huge. And IoT, the Internet of Things. And what's really interesting is how they tie it all back to sustainable development in the Sumatera region and Indonesia more broadly.
Ah, that regional connection.
Exactly. It's not just about teaching cool tech. It's about building engineers with a purpose for sustainability, right there where they are.
That makes a lot of sense. Okay, so the main goals, the objectives for this new curriculum, it's about relevance, meeting standards, sure, but really boosting what graduates can do, especially in these key areas. Industry 4.0, Society 5.0, renewables, AI, IoT, all linked back to Sumatera's development. So how did they know they were hitting the right notes? How did they gather the data for these changes?
Good question. Because, you can't just guess. You need solid data. And Itera, well, they really did their homework. They used tracer studies.
Okay, tracer studies. That's following up with alumni, right?
Precisely. Getting direct feedback on the old curriculum, the 2019 to 2024 one. What worked, what didn't, where did they actually end up working?
And did they find anything surprising there?
Well, maybe not surprising, but definitely informative. It showed graduates mostly landed in two main kinds of roles. One area, they label it PL1, was stuff like electrical design engineer, R&D roles, IoT, power systems, kind of the core technical stuff.
Okay.
And the other PL3 was more like project manager, technical manager, even entrepreneur.
Ah, so a mix of deep technical and more management or innovation-focused roles.
Exactly. It shows the range of where their grads go, and it helps Itera see, where the demand is, where their strengths are maybe aligning with the job market.
Beyond just tracking where they ended up, what about qualitative feedback? Did they talk to people?
Oh, yeah. The stakeholder feedback part was huge. They ran focus group discussions, FGDs, and they brought in a really diverse crowd. Academics, obviously, industry folks, they use the term GUDI, which covers business and industry, alumni, of course, and even current students. Getting all those perspectives is, well, vital.
So what were the big takeaways from those discussions? Any common themes?
Definitely. A few things really stood out. Alumni kept pushing for more outcome-based education, focusing on what students can do. And they wanted more flexible, adaptive elective courses, more practical application. And industry leaders, they were specific. Dr. Eng, Indarta Kunkoro Aji, for instance, really pushed for low-carbon technologies in electric vehicles.
Very current topic.
Absolutely. And things like battery management systems, smart grids, microgrids, even battery material technology. Plus softer skills, too, like science communication and bidding technology. They mentioned this industry goal of being carbon neutral by 2027.
Wow, that's ambitious. So industry is really driving that sustainability focus.
Seems like it. Even BRIM, the National Research Agency, chimed in, emphasizing electrical power infrastructure and R&D in renewable energy and energy efficiency, specifically for Sumatera.
Makes sense tying back to that regional focus. What about the students themselves? What did they want?
Their voices aligned pretty well, actually. Omar Akbari and Kenneth Gultam, the student reps, asked for more practical industrial activities and more research-driven learning.
So hands-on experience again.
Exactly. Echoes that broader demand. And there's some good strategic advice, too. Dr. Mohammed Amin Sulthoni warned that the vision shouldn't be too narrow, shouldn't limit the opportunities and potential development of the whole program. Keep it flexible for the future.
That's smart. Okay, so they listened internally, they listened externally, but they also looked outwards, right? That benchmarking piece.
Yes, absolutely crucial. They compared themselves against top universities, both in Indonesia and internationally.
Who are they looking at?
Well, nationally, places like ITB and ITES. ITB, for example, was noted for its focus on global technology innovation and making a big capstone project mandatory.
Right, that final big project.
And ITES emphasized technopreneurship and starting machine learning and problem solving, MLPS, much earlier. Internationally, they looked at places like NTU in Singapore, big on AI for engineers and research-based learning, and Tokyo Tech in Japan, known for collaborative projects and internationalization.
So it wasn't just copying, was it? It was about seeing best practices.
Exactly. Learning from the best, seeing what fits, and then adapting it, tailoring it for their own context in Sumatera, but still aiming for those, global standards. It's a smart way to build a program.
And they didn't just look outwards, they looked inwards too, right? Evaluating their own past performance.
Correct. That evaluation of scientific vision achievement. Basically looking at their previous curriculum's focus through the lens of faculty research and community service.
And what did that show? Where were their strengths?
It showed a clear strength in power and energy, Tenaga Electric. That area represented almost 35% of lecturer expertise, so a really strong foundation there.
But there's always a but, isn't there?
Usually. Well, the but was that other important fields needed boosting. Telecommunication was only around 17%, control systems about 13%.
So the evaluation highlighted areas needing more focus, more development.
Precisely. It's not just about courses, it's about strategically guiding the faculty's expertise too, making sure the whole program is balanced and, future-proof, data-driven adjustments.
Okay, so they've done the research, the feedback, the benchmarking, the self-assessment. How does all of that translate into the actual plan, the new vision for 2025 to 2029?
It leads directly to their new vision statement, which is quite clear and focused.
Let's hear it.
An excellent program studying the development of electricity infrastructure for sustainable energy transition in the Sumatera region.
Okay. Concise. You can really see the threads pulled together there. Sumatera, sustainable energy, electrical infrastructure. It's all in there.
Exactly. It directly reflects the feedback and the regional needs. And this vision then shapes the new graduate profiles.
Right. What kind of engineers are they aiming to produce? What jobs are they thinking about?
They lay out 4 main profiles, and they give examples, which is helpful. Things like electrical design engineer, sure, but also IoT solution architect, renewable energy engineer, innovation consultant, even technopreneur.
So a really broad range of potential careers. It's not just one path.
Definitely not. It shows the diversity they're aiming for, preparing grads for different kinds of impact across industries.
And underpinning these profiles are the actual academic goals, the learning outcomes, the CPLs.
Yes, the CPLs are the backbone. They're the main reference for designing everything else. And they're carefully aligned with national standards, the KK&I framework, and international accreditation requirements.
Are they all the same kind of outcome?
No, they're structured. They're institutional ones, sort of high-level values. Then common preparatory stage CPLs, covering foundational stuff. And then the specific program study CPLs, which get into the nitty-gritty of electrical engineering expertise. It ensures every course, every activity ties back to a specific intended outcome.
That structure makes sense, but how do they actually build the courses from those CPLs? How do they decide what to teach?
They start with defining the body of knowledge. For this, they lean on national guidelines from 4TI, which is basically the Indonesian Forum for Electrical Engineering Higher Education.
Okay, so a national standard for the core content.
Right. It helps define those essential building blocks. Think calculus, integral differential, or fundamental circuits, electrical and electronic circuits. These are core Bahan Kajanans, or study materials.
And it's not just what they teach, but how deeply,
Yeah,
Right.
exactly. They talk about ensuring depth and breadth. Graduates shouldn't just master theoretical concepts. They need to be able to adapt to changing situations. So, in terms of Bloom's taxonomy, moving beyond just understanding facts, which is like C2, towards higher levels like C4, analyzing, really critically engaging with the material.
Makes sense. And how does the overall curriculum break down, like percentages?
Yeah, they provide a clear curriculum structure.
Yeah.
About 58% is core, and main course is the math, science, fundamental engineering. Then, around 25% is elective courses.
That's a decent chunk for electives.
It is. Gives students flexibility to specialize in advanced stuff like AI, renewables, advanced control, wireless comms, whatever fits their interests and career goals.
And the rest.
About 17% is dedicated to collaborative and interdisciplinary courses, explicitly designed to build those cross-disciplinary collaboration skills.
That seems increasingly important.
Totally. And the whole program adds up to 144 credit units, or SKS, as they call it. Pretty standard for a 4-year bachelor's here.
You mentioned earlier they evaluated the old curriculum's courses against the CPLs. What did that evaluation uncover? Anything surprising there?
Yes, that evaluation of CPL in courses 2019-2024 was quite revealing. What's fascinating here is they found a kind of dominance where certain courses heavily mapped onto specific technical CPLs numbers 5, 6, 7, 8, and 11.
So very strong on the technical skill side.
Very. But the flip side was that other crucial CPLs like CPL3 related to regional development, CPL10 on communication, CPL14 on lifelong learning, these were less represented or even unmeasured.
So potentially an imbalance. Too much focus on pure tech, maybe not enough on broader professional skills or context.
That seems to be the implication. It highlights that tricky balance, technical depth versus broader competencies. The new curriculum is clearly trying to fix that, maybe by adding courses or integrating those aspects more deliberately.
It really shows the detailed thinking involved. And just on a practical note, they also created a whole new coding system for courses, right? Just to keep things organized.
Yes, streamlining the nuts and bolts. Table 3.7 lays that out, makes it clear for everyone involved.
Okay, so let's shift gears slightly. One of the really interesting, maybe even radical parts of Indonesian higher education right now is this Merdeka Belajar Kampus Merdeka MBKM idea, freedom to learn, independent campus. How does that fit into Itera's plan?
It fits in significantly. MBKM is a national program, and Itera is embracing it. It allows students to study outside their program study for 3 semesters.
3 semesters? That's huge. How many credits is that?
It's equivalent to about 60 credits.
Yeah.
Or SKS. So yeah, potentially almost a quarter of their degree spent on experiences outside the traditional EE department.
Wow. Is it a free-for-all or are there rules?
Oh, there are definitely rules. It's structured freedom, let's say. Students need a decent GPA minimum 2.75, no fails, and they need their advisor's approval.
Okay, academic checks.
And critically, whatever they do externally still has to align with the program studies scientific field and their career plans. It's not just about taking random courses. It needs to be relevant.
Makes sense. So what kind of things can students actually do? What are these MLPS activities?
The list is pretty diverse, actually. Table 4.2 gives examples. You've got the expected things like internship practical work or student exchange.
Standard stuff.
Right. But also things like dedicated research projects, independent study projects, even teaching at school.
Interesting. Getting practical experience in different ways.
Exactly. And it goes further. Humanitarian projects, entrepreneurship projects, village building, or thematic community service work. Even Bela Negara, which is like national defense or civic duty activities.
That's a really wide range. How does that count towards an electrical engineering degree, though? Do they get credit?
Yes, that's the clever part. Course equivalence. These external activities can be converted into several courses back in the EE program.
So their real-world learning actually counts on their transcript.
Precisely. They list specific courses, both mandatory and elective, that are eligible for this conversion. Things like Analysis Lingkungan Elektrohijau, that's green electrical environment analysis, or electives like Robotika, machine learning, data literacy, and AI.
So what does this all mean? What's the big takeaway from MBKM?
It means Itera is actively building adaptability, real-world experience, Interdisciplinary skills. It's a conscious move away from just classroom learning, trying to prepare graduates for careers that are going to be dynamic, maybe even unpredictable.
It sounds like a very forward-thinking approach, but with all this complexity, new courses, MBKM, evaluations, how do they ensure quality? How do they make sure this ambitious plan actually works?
That's where the quality assurance system comes in. It's built on outcome-based education, OBE principles, right from the start, aligning everything with those national standards and, crucially, industry needs.
And it's not just top-down, right?
No, definitely not. They stress it's a collaborative and participatory process involving lecturers, students, alumni, industry, regulators. Everyone has a voice in shaping and refining it.
How does that play out in practice, like during the semester?
During implementation, the focus is on student-centered learning, SCL. Active learning, not just passive listening. And every single course has a detailed plan, the Rincana Pembelaharan semester, or RPS.
The syllabus,
So
essentially.
a very detailed syllabus, yeah.
Yeah.
Then you have evaluation that happens periodically, formative checks during the term, and then a big summative review at the end.
And how do they gather that evaluation data?
Through various tools,
Yeah.
questionnaires, interviews, FGDs, and those tracer studies we talked about earlier, a mix of quantitative and qualitative feedback.
Okay, and they monitor things regularly.
Yes, that's the curriculum control part.
Yeah.
Semesterly monitoring of how well students are achieving the learning outcomes, how the MBKM activities are going, even checking if the facilities are adequate.
And it all feeds back into making changes.
Absolutely. Continuous improvement is the name of the game. It's designed as a loop. Evaluation leads to feedback, feedback informs changes, considering new tech trends like digital literacy or better Industry 4.0 integration. It's about constantly adapting to stay relevant.
If we connect this to the bigger picture then, this whole quality system isn't just bureaucracy, is it?
Not at all. It's essential plumbing for any university trying to produce graduates who are genuinely ready for, well, whatever the future throws at them. It ensures the program doesn't just look good on paper, but actually delivers.
So bringing it all together, Itera's 2025 electrical engineering curriculum really feels like a carefully constructed response to a world in flux. It's not just tweaking courses, it's rethinking the whole approach to produce engineers who are adaptable, innovative, tied to their region, but ready for global challenges. It definitely leaves you thinking. As technology keeps accelerating at this incredible pace, what other, maybe even more radical changes will higher education need to embrace? How do we prepare people for jobs that, frankly, might not even exist yet? It's that constant tension, isn't it, between deep, specialized technical knowledge and those broader, more adaptive human skills. Finding that balance seems key. Well, thanks for joining us for this deep dive into Itera's curriculum. We hope it gave you some useful insights into the detailed thinking that goes into educating the engineers of tomorrow.